NAFI would like to thank Sporties, AOPA, and 4Flight for sponsoring this episode of the More Right Rudder podcast. Thank you for joining us for another episode of the More Right Rudder podcast. This is the official podcast of the National Association of Flight Instructors. My name is Sarah Stout. I'm the Program Development Manager here at NAFI and the host for this podcast. Our guest today is Sean Sherman. Sean is the owner of Skeeter Enterprises, a technology company making radar and LiDAR altimeters for GA aircraft. Welcome, Sean.
Hi, thanks for having me on, Sarah.
Yeah, we're excited to have you. So these are kind of two branches or two, kind of parallel branches of technology that are really new kind of on the light general aviation side. You don't hear too much about radar altimeters for light GA, certainly
Right.
in the heavy metal. So for some background here, tell us how you got your start in these technologies.
Yeah, so I was working on a similar LiDAR technology when I was in the Air Force Research Lab stationed at Wright-Patterson Air Force Base. And so we were working on LiDARs for LiDAR altimeters essentially. And then my dad flies bush planes in Alaska, and he thought having a LiDAR altimeter for his bush plane in Alaska would be really nice for getting into some of those tricky bush landings. And so after I got out of the Air Force, I pursued it as a business, and here I am.
Oh, how cool. In the Air Force, then, did you go through like an engineering school with this or a technology school, or you were just dropped in and on the job training?
Sort of on the job training. So all the engineers in the Air Force need a bachelor's degree in engineering field of some sort. And so when they take us out of college, we're kind of already prepared in that aspect. But there is a 2 or 3 month course that engineers have to go through in the Air Force to kind of get them familiarized with the kind of projects that they'll be working on.
Oh, okay, cool. So a good background working in this. And let's start here. I think most flight instructors are pretty familiar with radar. We work with it for air traffic. LiDAR, I've heard of it, like kind of in applications like aerial mapping and some other things, but it's not a technology that I'm particularly familiar with. Could you walk us through what, some of those differences are between radar and LiDAR?
Sure, yeah. So the biggest difference is the wavelength of light that you're using between LiDAR and radar. So LiDAR is typically going to be, in these applications, is going to be infrared LiDAR, and the wavelength is going to be around 905 nanometers is typically what the infrared LiDAR wavelength is going to be. So it's pretty small versus radar wavelength. They're all part of the same electromagnetic spectrum, but they're separated significantly by the length of their waves. And so the radar wavelength is significantly longer. And so you get kind of different physical aspects that will happen. So radar will interact with aluminum differently than LiDAR will, and then they'll both interact with water in different ways. And so the way that they interact with their environment can really differentiate the different applications that you can use LiDAR versus radar. But on the other hand, they're both used in the same application in the sense that you're using a time of flight. So you send out the packet of photons, depending on the wavelength, either radar or LiDAR, and then you just measure how quickly it comes back to you. And so it's a fairly simple calculation to determine your altitude using a LiDAR or a radar. So the biggest difference, is like I said, their wavelength. The LiDAR, like I said, is 905 nanometers, which is just infinitesimally small versus your 24 gigahertz radar is 12 and a half millimeters, which is a significant difference in distance of the wavelength there.
Right. When you first brought up nanometers, I'm like trying to think, I'm like, what's a good way I can try to make this feel
It's a
more applicable to the audience? I'm like, nanometers just feel like, I mean, is this even like comparable to like a human hair or a thread of
Sure,
spider
yeah. So it's
silk
just
or
it'd probably just be a little bit thicker than a human hair, really. Probably like five thicknesses of a human hair versus, radar, the 24 gigahertz radar, 12 and a half millimeters. That's
yeah.
about an inch and a half there. So it's
Right.
a
Yeah. You
pretty
can,
sizable difference.
yeah, that's something, we all measured that in, second, third grade. So we
Right,
can,
yeah.
that we can relate to. I was struggling with the nanometers. With these then having those, kind of similar ways in which the technology is applied, what you said, where you basically send out the packet of information, I believe is what she said. And then,
Sure.
it comes back and you measure the light speed time difference. Um, but with those wavelength differences and how they interact with materials differently, how does that play into the different applications that in light GA that they might choose that a radar altimeter is better than a LiDAR, or do these altimeters have both? And then the pilot may need to choose, I want to use radar now or LiDAR now.
Sure, that's an excellent question. So the original radars that the big guys use in your 747s and stuff, they're using it's about a 4 gigahertz radar. And so it's a pretty long wavelength. I want to say it's probably, probably a 5 inch wavelength. The nice thing about the longer wavelength is that it's typically going to have a longer range for the same amount of power that's put into it. So if you want longer range, you're going to want a longer wavelength. And so the 4 gigahertz wavelength, the gigahertz is the frequency. So the frequency and the wavelength kind of get tossed back and forth simultaneously in these talks. But the 4 gigahertz frequency is a fairly long wavelength. And so as a result, you can get a lot longer range with it for the same amount of power. The radars that we're starting to transition to that your cars use, that I use in say Neptune, they're going to be more probably around 24 gigahertz, maybe 76 gigahertz. So it's that wavelength is, like I said, 12.5 millimeters. And so you're not going to get as much range with these, but you're going to get more resolution. So those big 747 guys, their radar altimeters are typically going to be good down to about 10 feet. After 10 feet, they're typically not going to get a good return anymore on those radars, just because the wavelength is just too long to really get much accuracy below 10 feet. Whereas 24 gigahertz, you can get accuracy within a foot.
Oh, wow.
And so it's significantly more accurate. And then you go to LiDAR, which has a really short wavelength, and the frequency is 331 terahertz, so significantly quicker frequency. Now you're talking, you can get sub-inch accuracy on these things. And so typically your LiDAR is going to be good for like plus minus a couple of inches. And so
Oh, wow.
the shorter that wavelength, the more accurate your system's going to be. And then there's other aspects, for instance, interacting with water is a big one. And so the LiDAR especially is typically not very good for water-based application.
Okay, so that's interesting. So there's a couple things I want to touch up on there. You mentioned something with that you use on Neptune. Could you let us know what that is?
Yeah, so Stadia Neptune is a derivative of the original LiDAR unit that I made, Stadia. And so this is the original Stadia unit here. And so you can actually see the LiDAR on the bottom. And so it's got one of these emits the infrared laser, and then the other one senses the infrared laser. Whereas Stadia Neptune, instead of using a LiDAR, uses a radar. And that's what I was alluding to earlier. The float plane guys really wanted something for the glassy water landings. And so the problem with LiDAR is that the water will absorb all the infrared laser energy that's being emitted, and you can't get a good return.
Mm.
So I switched to a 24 gigahertz radar, and now I can get a better return over the water. And so that's what Stadia Neptune is. It's a radar-based altimeter that's still useful for general aviation aircraft.
Okay, so that's interesting to hear those kind of differentiating or almost limitations between these two technologies because when you get into all that detail with the power and the wavelength and that's when you do start kind of getting those questions like what is right for me for the average GA pilot. 'Cause, if I walked into a pretend this was a storefront and it had all these wavelengths and powers on them, I wouldn't have a clue. Do I pick this one for what I'm doing or that one for what I'm doing? And so, yeah, let's explore more about that difference between the limitations of radar and LiDAR and what might be a better choice for different applications.
Yeah, I mean, boy, I could talk about this for a long time.
Well, let's just keep it simple. Our average kind of flight instructor, light GA. So, most
Sure.
of us are hopping around the patch over land, but then of course we do have to take into account that in certain geographies, you could be doing approaches that maybe cross a lake or a river or some other body of water, even though you're, well deep into, you're not coastal, you're not a seaplane trying to land on that body of water, but hey, say my home airport's got a big lake at the end, or like the airport I fly out of the most, one of the approaches over the runway comes over a quarry. So the ground is
Sure.
significantly deeper than where the field is. So how would we account for these, different types of geographies that we might be flying over, both in, topography and what that geography is actually made of, ground, water, holes in the ground, quarries,
Right.
things like that.
Yeah, so I think the most important thing is to, when you're buying one of these radars or LiDARs from either me or someone else, is to make sure that the person that's selling it to you really understands the fundamentals of the technology. If you're having a more, if you're kind of in a gray area as to what you need, because, maybe the sales staff doesn't really understand the difference between what's happening with the radar versus the LiDAR, and they're just trying to push a product versus maybe you do need something that's going to work over the water, even if you are on wheels all the time. Because, like you said, if you're landing on an island somewhere or you got a big lake, then maybe the LiDAR is not going to be the right option for you. Maybe you do need a radar, even though you're touching down on pavement all the time. But if your approach is over water and it's dark and you're coming in, the lights aren't working right, the radar is going to be the right solution for you, even though technically you're always landing on land. And so there can be some differences in that aspect, but typically it's going to be, if you're landing over water, you got to have a radar. If you're landing on land, you can use either. The LiDAR is just going to be slightly more accurate, but otherwise you can use both over land.
Okay. And so with both of those, like how do they handle things like sloping terrain or things like that, so if you were approaching with it, just constantly tell you you're kind of within this range, assuming the slope is pretty similar to your glide path, or if you encounter something like, there's a dip in the geography, because there's another airport I used to fly to regularly was up on a little bit of a plateau, and so there's the end of the runway, kind of like the overrun area, and then a pretty steep hill. So if you were approaching to land on that end, you would your above ground level essentially is quite a bit higher until you get just over, that approach end, that last little bit of the runway, and touch down. And so you'd get, if you were measuring that, you'd get some pretty varied numbers on your way in.
Yeah, and that's going to happen with either the radar or LiDAR altimeter. You're going to get essentially the immediate measurement underneath your airplane. And so the radar will kind of average it a little bit more than the LiDAR will. The LiDAR it's literally a laser. And so whatever it reflects off of, it's going to tell you the distance to that exact object. So if it's reflecting off of one leaf on a tree, that's the distance you get is to that leaf on that tree. Versus the radar typically uses a significantly wider beam. It's typically like a 30-degree beam. And so the radar is trying to get more of an average of things that are underneath
Okay.
it. But still, it's going to tell you the distance beneath your, exactly underneath your aircraft. And so if you're flying over the quarry, like you're saying, it's going to tell you, okay, that's where the bottom of the quarry is.
Okay.
If it can range that far. A lot of the LiDARs will typically only range like a couple of 100 feet.
Mm-hmm.
And so if the core is deeper than that distance, it's not going to give you a return. But if it does give you a return, it's going to say, okay, the bottom of the quarry is that distance. And then as soon as you get over the top, it's going to instantaneously tell you, okay, now instead of 200 feet, you're 10 feet.
50 feet.
And so
Yeah.
it will tell you that distance pretty immediately.
Oh, okay. So, yeah, so that's just interesting. I'm trying to, think through, the practical aspect of a flight instructor and a pilot, maybe trying to, get familiar with this, flying with this technology for myself, of course, before integrating it with a learner. But, does that look? What do you handle that? And then let's talk about this. How do you actually get this information in the cockpit when you're flying? Because it's, are these certified and installed systems, or because that I'm just watching dollar signs fly out the window with that, or the average flight instructor is gonna be like, nope, or what? essentially how accessible is this technology to your average flight instructor?
That's the big question. How many aviation maintenance units is it going to cost? Yeah. And so that was something I worked really hard in engineering Stadia right from the get-go because, if it's got to be certified and it's got to be put in with an A&P, I mean, thousands and thousands of
Right.
dollars right off the bat. I mean, you can blink and all that money's gone versus what I've done is for my Stadia, this will strap to a strut. And so you can see the profile on this. This one is specifically for Cessna's, really for 172s especially. And so because it's a temporary attachment like a GoPro, you don't need an STC to install this on your airplane. You just put it on there, it's a temporary attachment, and you go. And that's it. And so because you don't need an STC, because you don't need an A&P to put it on, you get to save a lot of money that way.
Right.
And so even on the front end, when this unit is going to be less expensive compared to just the baseline price of any other LiDAR, that's great. But on the back end, when you're talking to the A&P, how many hours, how many weekends is it going to take to install some unit? That's where the money really starts to drain out of the bank account. And
Mhm.
then the flip side is, having a temporary unit, if you own a fleet of training aircraft, you can take this off and put it onto another airplane. Instead of having to have a specific altimeter for each airplane, you can take this and use it for a fleet of airplanes. So that's the really easy part. That being said, a lot of people do want permanent attachments. And maybe, they're willing to pay the A&P to put it on there, or they have an experimental airplane, they can put it on there themselves. And that's getting really popular, putting LiDARs in experimental airplanes.
Hmm.
And so it's just a matter of how comfortable you are putting the wires on. Typically, the permanently mounted LiDARs and radars will kind of come in a kit and it will explain either to the pilot or the A&P how to put this on there, what power requirements are needed. And then, like you were saying earlier, how do you get this information to the pilot? And that's the $1 million question, really. Um, I don't know of any unit that doesn't use audio to get that
Okay.
information to the pilot because you don't want to be looking at the numbers on a dashboard somewhere when you're trying to land this thing. You need to be looking
Right. Yeah, that's what
at
I
the
was like. So,
cockpit.
okay, if the accuracy is really, I suppose if you were flying somewhere where your airport was, largely over flat terrain where it could get a reasonable reading for, even call it that last half mile, that's great. But I'm thinking like the airports I fly at, like, yeah, you're in that last couple hundred yards before the pavement where I'm actually going to get a reasonable reading because of the topography.
Yeah,
And
exactly. And so that's what the audio portion is for because you want to be eyeballs outside. And so for instance, Stadia will Bluetooth to an app on your iPad or iPhone or whatever. And so, typically if you're flying around with like a Bluetooth headset or your David Clark is plugged into your phone, the app is running connected to this, and now you're getting those alerts directly over your headset because the phone is producing the tones or the voice alerts to tell you how high above the ground you are. And so you're going to get audio alerts through your headset that way. I think every single radar and LiDAR altimeter is doing something similar like that. Some of them will plug into your avionics, and so you'll get the tones through the avionics. And so maybe your Bluetooth, you're plugged in that way. And so you're still going to get the tones. I don't know of any where it's visual based. That would be a huge error, in my opinion, where you're trying to look at the distance and then trying to land the plane simultaneously. I think that would be an enormous error.
right, that's what I was thinking, even if it was some like color coded thing that, once it was within, X number of feet, it turned down to this, that would still be, that this is a real critical phase of flight where you'd be using this. And we want your eyes outside, 99% of the time. Like you're going to come in and, peek at your coordination and peek at your airspeed and a couple of handful of things, but it's usually just a very targeted in and back out. And to add something like this into the flow, it is just more heads down time and um may not be the most desirable. So oral seems um a pretty reasonable way to do it. And can the pilot say like, okay, I want alerts at, these certain intervals, like every 5 feet or versus 10 feet, or is this kind of baked into these systems as they come?
It depends on the system. a lot of these are probably going to be, they're already set at the shop, and then you kind of got to deal with what you got. For mine, for Stadia, there is a option to set it at what you want. And so that's kind of the nice thing about having the app on the iPhone is if someone comes to me with a good idea, hey, I'd like this, I can just push it out in an update, and then everyone gets to have that same idea for all their Stadias. And so, for instance, for my app, you can set at exactly what altitude you want to start hearing alerts
Mm-hmm.
because you don't care when you're 100 feet above the ground. It's that last couple of feet where the landing gets tricky, and that's when you want that extra peace of mind. Okay, so a lot of pilots will set, even though this thing has a couple hundred feet of range, they'll only set it for like to go off at 10 or 15 feet. And so they'll get an alert at that threshold altitude, and then it'll start tying them down from there. So they're not
Okay.
getting bothered with all these audio tones when they're a couple hundred feet above the ground because you don't care at that point. You know you're not going to crash into the ground when you're a couple hundred feet above the ground. It's that last couple of feet where it gets really critical, and that's where these radar and LiDAR altimeters are really handy. Is talking you down that last couple of feet so you can really squeak those landings in.
Okay, yeah, and the other thing going around in my mind was like, okay, if I'm getting these alerts starting at like, 100, feet or more, I've always been based out of busy training airports with towers and things like that. So I was like, is this going to interfere with comms a lot if I'm having to listen to this while I'm still, I've had some sporty things happen, and then
Right,
those
yeah.
last, that last short final quarter, eight of a mile, people cross the whole short line, or someone's dawdling down the runway, or all sorts of things. So we're all learning.
Yeah, that's
And right,
exactly
and
it.
that's why I was kind of wondering, like, how would this interfere with comms when it's nonstop? But if you can program it where it's just those last 10, 15 feet, not that nothing can happen in that window, but it is a lot less likely. It's more likely the pilot to be making their own call to go around versus tower or somebody that, because if they're going to call it, not that it's impossible in those last 10 feet, but in my experience, if Tower was going to call me to go around, it's been sooner due to some
Right,
other, aircraft on the ground, just taking their time. I've seen all sorts of things.
right.
Coyote on the runway. I got called to go around once for a coyote on the runway. So, all these sorts of things. But it was much higher than 10 feet.
Right.
So if it's that, you're not, it's more likely in the pilot's ballpark to go around at that point than some external factor that's going to call you and say to go do this, where it would really be interfering with comms was my thought with the alerts.
Yeah, I very specifically made sure that it was not going to interfere with comms. You can set the alerts to go off higher, but most pilots, like I said, they prefer it, just in the last 10 feet or so. So that way it's definitely not going to interfere with comms, and it's helping you with that most critical part of the landing phase.
Mm-hmm. Yeah. Yeah, because that's when it can be, depending on the aircraft you're flying, can be more difficult to judge. You're down lower and with the nose up a bit, you're relying more on that periphery
Exactly.
to do all that. So, with all that, we probably should touch on at least a couple of safety considerations with this. We've kind of touched on comms, and then other things we would need to consider this, along with any other technology, is the potential for errors or failures. I'm guessing if this thing is strapped to the wing out there, it's on a battery.
Yes, it is on a battery, and so it's on a rechargeable battery. It's got a built-in overcharge circuit on it to kind of prevent from, any overcharging the battery or damage to that sort. So there's safety features built in. And then, having something on the wing strut or on a tie down ring for other versions, there's just the pilot's got to make sure that this thing is secured attachedly.
Hmm.
And so this model especially has been on bush planes in Alaska and been bounced off about every rock imaginable. So I know it's sturdy, but if the pilot doesn't install it correctly, there's certainly the potential for some interesting time in the cockpit as you see this thing flailing outside your window.
Right. And even aside from that, there is still risk that the battery will drain sooner than expected. And we pilots would want to be cognizant that, yeah, you have this tool out there, but there are a number of failure points in getting that information to you. So that battery could fail, especially if your flight got extended for some unforeseen reason, or maybe your phone battery died. I've seen a lot of screenshots from like ForeFlight and the battery is at like 2% or something like
Oh
that. And
yeah.
it's like, come on, guys. Um, so that's a potential failure point in getting this. And certainly I've had my Bluetooth on my phone just do wonky things every once in a while. And so, any pilot who's using this while it's great information, that should be cognizant that you can't just sit there and wait for it to announce that you're at 15 feet. You need to be able, to recognize and have still have those visual cues on your own in anticipation that in the event any of those elements along the link of that chain from, the device capturing the actual altitude to the process of getting it to you could really break down at any point, and you just won't get that information, and you probably won't know you're not getting that information till it doesn't show up in the last 15 feet.
Right. Yeah, that's a great point. Yeah. So what I typically tell users is to, when they're on their downwind, open the app real quick, just make sure everything's still working. You got a good Bluetooth connection. It's probably going to be too high for it to get a good return, but it'll still allow you to know that the LiDAR is still working. And so just quick check on your downwind. And the nice thing about this app is that it can work in the background. So you can still be using ForeFlight on your iPad, quick checks the Stadia app, make sure everything's working. And then you can be reasonably sure that it's going to work when you get on your
Mhm.
final leg there. I mean, it's not impossible that it will stop working, but that's a 1 minute window for it to stop working. So you really
Right,
limit
yeah.
a
So
lot of
not
errors in that
impossible, but
point.
yeah, but it is something else to think about in your workload management if you do want to add that, that essentially checklist item.
Right. Yeah.
And so that is heads down time, that is moving around apps on there. So, something to think about in balancing, your workload. If workload is high, is that a step that you skip, kind of, trusting that it's most likely there, but also cognizant and very prepared for in the event that oral alert doesn't show up.
Right. And I always tell pilots, and this is just in general with everything, don't trust these instruments, for everything. I
Right.
mean, even, yeah, these things aren't fail-proof. I mean, nothing on the airplane is fail-proof, as we all know. The engine could go out at any time. So, always be looking for your plan B. Don't trust on this instrument to always be working for you. It's there to augment you. It's not there to replace your piloting skills. And that's the key point to really hammer home is it's only there to augment you. It's not replacing anything. Do not rely on this 100%.
Right. So it's a fantastic situational awareness tool. Um, but it needs to be recognized. Yeah, it has its limitations, and it is still the
Absolutely.
pilot still needs to be able to do what they need to do without it.
Yes, for sure.
And so overall, this is a really cool technology. And especially as for flight instructors who might be getting transitioning pilots into more advanced aircraft where those things are those landings and that might happen faster or it's more critical or I used to transition a lot of people up into a 182, and so now you're landing with that little bit of power and it's heavier, and especially when these pilots were used to flying lighter aircraft like 172s or even light sport aircraft, trying to move them up into a 182 and like, well, this thing weighs twice as much. So, having a tool like that could really help because your whole body position and sight picture and just general moving between makes and models can having a tool like that could really help. Like, oh, okay, so this is what this looks like in this airplane.
Yes.
And staring that down. So
I hear that a lot from the flight instructors and student pilots. A lot, a lot. That's the exact scenario you were talking about, transitioning from a smaller airplane, maybe they're flying a 150 or 172 and they go up to the 182. And now that gear is, an extra foot longer. That airplane's a foot taller and it's that much heavier and their sink rate's that much quicker. That's
mhm.
exactly what I hear from instructors and student pilots. It's not that they can't land. Everyone's learning to land, but it's getting that line of sight, getting those peripherals exactly where you need them to be. And when you transition, those peripherals are different now. And so and obviously everyone's trained to, you make transition and you adapt. But how many of us are guilty of bouncing that, you know? You, especially
Personally,
an
not
instructor,
me.
I
I've
mean, you
never
might have to.
absolutely planted an airplane after.
I mean, you probably have to like have an orthopedic chair when when you're instructing some of these guys. I mean, those bounces can be really brutal.
Or
And
transitioning, like I always, when I was transitioning people into 182s, we would always start with just normal landings, getting that all honed in, and then like, okay, well, now your flap motor failed. Let's do a no flap landing, and that is a wildly different animal. And so for trying to, get it, even just to get it slowed down, much less the sight picture, and yeah, I've seen some interesting sync rates, and we end up doing a lot of go arounds trying to get a no flap landing
oh, I'm sure.
in. But something like this, but that's a big part of it is the sight picture is so different, because of how much those flaps change the wing shape and just the pitch angle at the same airspeed. And so, a tool like this that could all of a sudden say, oh, okay, so this is where I am when the sight picture is so different. It is a tool that could really help kind of ease that transition and help smooth that out.
I've had that exact conversation a lot of times. You're exactly right. That sight picture is critical for these landings. And so that's where the instructors really enjoy this and the student pilots is, you know, the best example I have is an instructor came to me and says, I will have that pilot float at exactly 3 feet down the runway. And that we both know it's exactly 3 feet because the LiDAR is telling us it's exactly 3 feet. And so they'll go the whole length of the runway. They won't touch the ground at all. The pilot or the instructor will say, get that sight line in because this is exactly where 3 feet is. This is where you need to be. This is your sweet spot. And now it's cemented in that pilot's sight line of, okay, this is exactly where 3 feet is. And then when you transition, you can do the exact same thing on a bigger model airplane. You put that LiDAR on there and say, okay, this is what 3 feet looks like in this airplane. And the pilot will know, oh, maybe I've got 3 feet underneath the gear, but I'm actually, 7, 8 feet up in the air now. And so that sight line can be quite a bit different. And so that's where it really shines for instruction, is really cementing in that sight line. And then, maybe save a little extra wear and tear on maintenance.
And tires and brakes and things, yeah.
Exactly.
Yeah. Oh gosh, yeah, the stories that I'm sure we can all tell on tires and brakes,
Right.
in
Yeah.
training
Yeah. If it
enterprises.
saves you from one bad tire, it's already paid for itself. So,
Yeah, right. Yeah, those are expensive anymore. All right. Well, Sean, thank you so much for coming on More Right Rudder today. We appreciate you introducing us to these new types of technologies that are out there. And so hopefully people will take the time to kind of explore if this is something of interest or right for them and understand the technologies, and find ways to safely incorporate this into training.
yeah, perfect. Thank you so much for having me on, Sarah. I really appreciate it.
Yeah, we're thrilled. Thanks so much.